Hi there, everyone. This is this video is going to be about electric circuits and the entire unit. I know I made one little video earlier trying to teach you about mixed circuits, but this is going to be like an overall review, and I'm going to try and do a question from every basically topic that we learned in the class. And before I start off, I wanted to say I'm not a real teacher or professor. I'm just a student. So, yeah, just as a disclaimer. So, before we get into the problems, I'm going to review the notes with you. And basically, what you should try and do is memorize the formulas because they're really important. And let's say if the teacher doesn't allow you to use your formulas, even if you can apply them, it would be really useless for you, and you're most likely going to fail the test. So, memorizing the formulas is a must if you want to do really well, and if you know your teacher doesn't let you use a formula sheet, or like she requires that, or he. So, I made a page worth of notes, and some of the things I say might not necessarily be on it, but in general, everything that's on this is pretty important, and you should know, or at least you should be familiar with this. So let's start off with over here. This is mostly in electric current, and basically what it is that I, which is electric current, equals Q over T. And as you can see over here, the variables, Q equals charge, and charge is always measured in coulombs. And the thing with coulombs is, let's say if you don't know, if the question doesn't explicitly say coulombs, then if it has a capital C beside it, then that refers to coulombs, because that's like the symbolic version of it. Then T is time, and time, as if you didn't know, is measured in seconds. So this is an important thing, and it's really easy to make a mistake. Like, you could know the substance, but it's really easy to make a mistake if, for example, you forget to convert it into seconds. And all of this equals to the electric current, which is measured in ampere, or also called as amps, and the symbol for that is a capital A. Alright, so that was the first equation, and it is useful. Sometimes it's not, like, it doesn't give you the answer directly, but many times what many questions will do is that you'll need to use this formula or to get your final answer. So over here, this is used generally to find the number of excess electrons, but like depending on how they rearrange it, you could be asked to find charge or number of excess electrons. Like I said earlier, Q is charged and it's measured in coulombs. N is the number of excess or missing electrons. And E is a constant, meaning that it's always going to stay 1.6 times 10 to the power negative 19. So that's the second formula. And most likely what most questions would do is they would give you the current and time. That way you have to find out the Q, and using that Q, the charge, you have to find out N. So you see how they're related? Next is, this is called the Ohm's law, where R, resistance, equals V over I. V is voltage, which is measured in volts, and I is electric current, like I said earlier, which is measured in amperes or amps. And so those are three important formulas. There's more. I'm sorry, but there's more. And now this formula. This formula is generally used to find the resistivity, but most of the times, from what I know, most questions will ask you for resistivity rather than resistance. But the equation is resistance equals resistivity, which is measured in ohms meters, multiplied by length, which is measured in meters, the SI unit, divided by A, which is area, and that's meter square. So that was basically everything on electric current. Now the next part is electric power. And note that many times, even though there are two different sections of the unit, like there could be a question where you would need to use something from here to get an answer from here. So let me start by teaching this part. Power equals voltage multiplied by current. Power is measured in watts, which is represented by a capital W. Voltage is measured in V, or volts. And current, like earlier, is measured in amperes or amps, and that's a capital A. So, and obviously, like always, you can always be given two. You need to be given at least two, or have some method of getting two of the variables. And what you need to do is you just find one. Then the next formula, which is in some sense the last formula, depending on how you see it, but the next formula is energy. Energy equals power multiplied by time. Energy is a bit interesting because it has two ways of being measured. The first is in joules. If the question asks or gives you joules, then generally, not generally, you have to have the answer in watts and in seconds. These three have to be together. If the question has or asks for kilowatts per hour, then power has to be kilowatts and time has to be in hours. So these are like three, and if you see it, then it kind of makes sense. Watts per second equals joules, kilowatts per hour equals kilowatts per hour. So that's electric power, and now we're into the circuits, which are interesting. So, some definitions. REQ is the short form of equivalent resistance or effective resistance. And in a series, REQ, I mentioned this in my previous video, but in a series circuit, REQ is basically really simple to find. All you do is you take the first resistance, which is basically number of ohms on the first resistor, and it doesn't even matter which resistor you call number 1 or 2, and you add it with the second one, third one, depending on how many resistors there are. So if there's 10 resistors, you add the resistance of all 10 and you get your REQ. And the interesting thing about series circuit is that the current always remains the same. So in a series circuit, the current remains the same. And in case you don't know what a series circuit is, I'll just draw out a quick rough sketch. Alright, kind of a poor drawing, but you get the idea. So in a series circuit, the current over here is going to be, let's say if this is X amps, then this is going to be X amps. No matter where you go in the circuit, so over here, X amps, no matter where you go in the circuit, the current is going to remain the same. And that's basically really all you need to know for a series circuit. And like I said, this formula, R equals V over I, is really useful as in all types of circuits. If you see a circuit, that formula is like always going to be used. Well, I can't say always, but it's generally going to be used heavily. And the last thing I have on the notes is parallel. And parallel, to find the equivalent resistance or REQ in parallel, it's a bit more confusing, and I showed you a shortcut in my other video, but I'll say it again. I'll just repeat it again over here. So basically, this is the formula, and 1 over REQ, or also known as inverse of REQ, equals 1 over R1 plus 1 over R2. And like I said earlier, the dot 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 just depends on how many resistors you have. And the special thing with parallel circuits is the voltage is always going to stay the same. I have no idea why I have resistance here, but it's just voltage. And again, if you don't know what a parallel circuit is, oh no. Well, basically, it would just be, I'll just make it a bit simple. Like, this is a really simple one. And it differs. Right? So you see how they're parallel to each other? So this, and this. There's like different branches. And like the current will not stay the same in this. But the voltage, let's say if it's X volts, then it's going to be X volts here and X volts here. So like that, the voltage remains the same. And for now, I did the theory of basically everything we need to know. And mixed circuit, there's a little bit more. So in a mixed circuit, I'm actually going to do it in the next video I upload, which is going to be soon. It's going to be at the same time I upload this. It's just for the time length, I have to make it a bit shorter because I'm required to. So in the next video, I'm going to do about 9 to 10 questions regarding all of these things, and I'll show you how to apply these ones in some sample problems. And I'm also going to be teaching mixed circuits in the next one, and on top of that I'm going to be teaching ladder circuits, which I feel is somewhat confusing, so I really recommend watching the next one to know how these are applied. But until then, you should memorize 1, 2, 3, 4, 5, 6, 7, 8. These 8, and if you count this, these 2, then like basically these 10 things, and you should be already set. And then the next video, if you're able to understand and comprehend, then you'd understand the topic really well. Alright, that's all for this time. I'll watch the next video, and if you like the video, like